Here we are going to learn how to graph parabolas using a 5-point approach. On the worksheet for introduction that we did in class, I gave you the x values to use in your chart for the parabolas. Here you're going to learn how to pick your own values for the chart and only use 5 points. Our general form of a parabola is a trinomial, ax squared plus bx plus c, where a is the coefficient of x squared, b is the coefficient of the x term, c is the constant right here. One notation you're going to see is right here, this h parenthesis x. It means h of x, not h times x. Okay, so h of x, not h times x. And what you're going to do is replace the h of x here with just a y right here. It just stands for y when we do our charts. The h could also be a different letter. It could be g of x, or it could be f of x. All of those would get replaced with y. Our first step in graphing the parabola will be to find the center line, which is called the axis of symmetry. We have a formula for that. This is a new formula right here. X equals negative b over 2a, where a is going to be 1, b is going to be negative 6. Okay, so we're going to fill those values into our formula. X equals negative b. So negative b itself is negative 6 all over 2 a, which is 1. So the top will be positive 6 and the bottom is 2, so we get 3. Now we're going to take the axis of symmetry value of 3 and put it in our chart in the middle. So the next step is to take our x value of 3 and find the y value that goes with it. So we are going to substitute 3 into the original equation and find the y value. So we have 3 squared minus 6 times 3 plus 5. So we have 3 squared is 9 minus 18 plus 5, which will equal out to negative 4. The negative 4 is the number we're going to put in our chart for the 3. This point, 3 comma negative 4, is our vertex, and you will see that when we plot it on our graph later. Our next step is to find the x-intercepts. Those are the points where our graph is going to cross right on the x-axis line. If a point is right on the x-axis, the y value will be 0. So we're going to take our equation and make the y be 0 and solve the equation. So here I set the y value to 0, so we have a trinomial that equals 0. We're going to factor and get two solutions, and those will be our two x-intercepts. So we have a trinomial. We will factor it to two parentheses because we have just x and x at the beginning, and we will need 5 and 1 on the ends, negative and negative to get the negative 6. So negative 1, negative 5. And then we have to set these each equal to 0 and solve. So here I did x minus 1 equals 0, x minus 5 equals 0, and we will get x equals 1 and x equals 5 for our solutions. So we're going to take these two values and put them in our chart and put them in order. Now the y values will be 0 on these because this is how we found the points, by setting the equation equal to 0. Step 4, we are going to be skipping. What it states is if there are no x-intercepts, we would pick two more x values to put in our chart. For the problems we are doing at this point in the semester, we will always have x-intercepts, so we will skip step 4. Turning to the back page of your note packet, we're going to start with step 5, but let's rewrite the equation we are working with. So there's the equation, y equals x squared minus 6x plus 5. And let's also transfer over our points into our chart that we've already found. So there we have our points from the front side. Now we're going to look for our y-intercept. A y-intercept is a point that will be anywhere on this y-axis line. The coordinates of a point would be 0, comma, maybe 8 or 9. It could be 0, comma, negative 6 or 7. Let's label our x and y axes also. So here I've labeled the x-axis and the y-axis vertically. To continue with finding the y-intercept, we are going to put 0 in for x. So we're going to put 0 in our chart on the left side. So here we put 0 on the x side. So we're going to find the y value by putting 0 into the equation. So here I've put 0 in for x, so 0 squared minus 6 times 0 plus 5. This will be 0 here, and this will be 0, so we're going to get the 5, which is the c value, or the constant, in our trinomial. So this 5 here is going to come down in our chart for our y value. We're ready to plot the 4 points that we have, and we will find the 5th one in a minute. There I have plotted the y-intercept, which is 0, 5, so left or right, nothing, and straight up 5. Here I've plotted 1, 0, and next we will plot 3, negative 4. Here is right 3, down 4, so 3, negative 4, and next will be 5, 0. So here's 5, 0. The next thing we're going to do, it's a good idea to always draw a dotted line for your axis of symmetry. Our axis of symmetry occurred at this middle value of 3. So I'm going to draw a dotted line at 3, a vertical dotted line. So here is the vertical dotted line through x equals 3. That is our axis of symmetry. Because parabolas have symmetry, we should be able to find a 5th point that is the reflection point for this y-intercept. If you notice, if you look at the units, it's 1, 2, 3 units away from our axis of symmetry. So to find the reflection point for the y-intercept, we can count 3 units to the right of the axis of symmetry. 1, 2, 3. So we can plot a point right there. So now we have a symmetrical parabola that we can sketch, and let's make sure we draw a rounded curve at the bottom. Parabolas do not come straight down to a point. The sketching tool on the device I'm using is a little difficult to use, but this should be a nice rounded shape down here. Extend these up and put arrows on both sides. And we should also place our 5th point that we found right here in our chart as well. So that would be 1, 2, 3, 4, 5, 6, right 6, up 5 to balance out with the y-intercept. So here I've placed that reflection point. So we've finished graphing our parabola. Now we have to answer these 5 questions down here at the bottom. The axis of symmetry is what we started out with. That's the equation of the line x equals 3. You must write this with the x equals to indicate it is the actual equation of a line. Otherwise we would just have the number 3 and not know what it really refers to. So now we've got to write the coordinates of our vertex. Your vertex right here is that low point, and it's right on your axis of symmetry. So this right here, 3, -4, is our vertex. We just need to come down here and state it and put parentheses around it right here to indicate that it's an actual point. So the parentheses are required here. So here is our vertex. Next, we're going to list our x-intercepts. So our x-intercepts up in our graph were right here, the 1, 0, and the 5, 0. And they were right in our chart. But we do have to actually list them down here as points, so we need the zeros. So x-intercepts are always a number first, comma 0. So here's our x-intercepts. And our y-intercept, there would be one of those. It was right here, right on the y line, so that was 0, 5. And we want to write that with parentheses around it as well. So here are the coordinates of our y-intercept. Some students get these two confused. Just think about it and don't reverse them when you answer the question. And one thing we could have looked at the beginning was, does it open up or down and why? Clearly this parabola opens up. And if we look back on the first page of this handout, the very top right corner down a little bit, it talks about if A is positive, the parabola opens up. And if A is negative, the parabola opens down. For this problem, our A was the leading coefficient of x squared, which was 1. It was a positive 1. So if this leading x squared term is positive, the parabola will open up. If it starts out negative, it will open down. So we know before we even graph this that it should have opened up. So this parabola opens up, and why? Because A is greater than 0, which means A was positive. So that means that we had a positive x squared to start out with. So this was a simple introduction to graphing a parabola using the 5-point approach, which the 5 points are your vertex, the 2 x-intercepts, the y-intercept, and the reflection point. I am going to do another example of a parabola that starts out with negative x squared, so it will open down. That is in the next video.